pressure or the dew point pressure of the real mixture will be your final exam question. So make sure you read the example 12.4 and understand all the steps, and send me a question if you have any, if there is any part that's not clear. So to find the bubble point pressure and the dew point pressure of the mixture, you can also go back to the equations 12.15 and 12.16. Okay. Again, we know if I'm interested in the bubble point pressure, the bubble point pressure is where the first gas bubble appears. Basically, the number of moles in the gas phase is zero. The total number of NL becomes the total number of moles. So number of moles in liquid is equal to the total number of moles. So they can cancel out. So the summation of Zj times Kj becomes equal to 1. So at the bubble point pressure, the summation of Zj times Kj becomes equal to 1. Zj is given. The reservoir temperature is given. So what is the pressure at which, if I read the Kj, this summation becomes equal to 1? That's the bubble point pressure. The same goes to the dew point pressure. I know at the dew point, the last droplet of liquid is gone. So NL is 0. Ng becomes equal to the capital N. I saw it cancels out. So what is the pressure at which, if I read the Kj, the summation of Zj over Kj becomes equal to 1? That's my dew point pressure. So we are going to look at these two cases. So in the case of bubble point pressure, I need to find the pressure at which, if I read the Kj, the Zj times Kj becomes equal to 1. And in the case of dew point, I need to find the pressure at which, if I read the Kj, the Zj over Kj becomes equal to 1. In the previous example, I already told you the good guess value for the bubble point pressure and the dew point pressure is the ideal bubble point pressure and dew point pressure. For the ideal solution, it's very easy. We know the bubble point pressure was simply Zj times PVJ. So Zj is given. The PVJ I can read from the Cox chart. Sum is Zj times PVJ. I can find that summation. That's a very good guess for your bubble point pressure. So what I would do, I would find the ideal solution bubble point, and I use that pressure with the reservoir temperature to read the Kj values and see what this summation would look like. And then depending on that summation, I know what would be my next guess. Because if you have a guess values far away, then you cannot do the linear interpolation. Okay, so that's the whole point. So for the bubble point, I first assume the ideal solution. I calculate the Zj times PVJ. That's my initial guess. I use that pressure, the composition which is given, and the reservoir temperature to read the Kj values and calculate the Zj times Kj. If that's equal to 1, it means my solution is behaving exactly like the ideal solution. If not, depending on what that number is, if that number, the summation of Zj times Kj is less than 1, then I know the pressure I picked is more than the bubble point. So the next guess should be a pressure less than what I had in the initial guess. Okay. If the summation of Zj times Kj is less than 1. So the same goes for the dew point. Again, for the dew point pressure, I know the dew point pressure is equal to 1 over summation of Zj over PVJ. So again, Zj is given, PVJ is comes from Cox chart. I can find the ratio of Zj over PVJ. 1 over that gives me the dew point. And I can use that dew point pressure as an initial guess for my real solution. How? Again, the Zj, I know it. So the Zj, I know it. For Kj, I use the pressure that I find using ideal solution, reservoir temperature, and the composition. I read the Kj values, and then I calculate this summation of Zj over Kj. Again, if that summation is less than 1, I know the pressure I picked is less than the dew point. So for my next guess, I pick a value greater than the initial guess. And then I will do this twice, and then I do the linear interpolation to find the bubble point. So example 12.6 is basically showing you how to find the bubble point pressure. Okay, so it says assume find the bubble point pressure for 1 pound mixture when the temperature is 150 and the pressure is 200. Assume that the equilibrium chart is valid. So the composition is given. I know at the bubble point the summation of Zj times Kj should be equal to 1. So here what it does, again, for the first initial try, it uses the bubble point pressure of 247. Okay, this bubble point pressure is coming from ideal solution. Okay, so the bubble point pressure that's coming from the ideal solution, which was simply ZJ times PVJs, has been used, okay, as our initial guess. So we used the 247 psi, the 150 degree Fahrenheit, and we'll read the K values for all the mixtures. And then we calculate the Zj times Kj. If we do, the value becomes 0.969. It's not equal to 1. But the summation is less than 1, okay? So I know if the summation is less than 1, the pressure that I picked is more than bubble point. So this 247 is more than bubble point pressure. So I need to, for the second guess, I need to have a lower value. So here it used 220. It picked a lower value. Why 220? You can use 230. You can use 210. It's just a guess value. But the guess value should be lower than my initial guess because the summation of Zj times Kj is less than 1. And based on this, this tips for the calculation. It says if the Zj times Kj is less than 1, your pressure is more than bubble point. So you pick the next pressure less than that. So if you pick 220 for 150 temperature, read the K values. This time your Zj times Kj becomes more than 1. So at 220, your summation is more than 1. At 240, your summation is less than 1. Then you can write the equation for this straight line and find what would be the right right pressure that gives you the summation being equal to 1. And that becomes the bubble point pressure for the real solution. The same goes for the and this is basically the confirmation. You don't have to confirm it. As soon as you find this through the linear interpolation, you are done with this example. Okay, and the same is valid for the dew point pressure. Again, for if the question was to find the dew point pressure, then what you would do, you would first find the dew point pressure from the ideal solution, which was 1 over the summation of Zj over Kj. Use that pressure, the reservoir temperature of 150, to read the K values and calculate what would be the summation of Zj over Kj. Again, if the summation is less than 1, then it means your pressure is less than dew point. So next guess, you assume a larger pressure. And then you have to get, you calculate this for the next pressure. You have to guess, do the linear interpolation and find your dew point. So one of these would be your final exam question 12.6, 12.7, or question 12.4, okay? These calculations are very important, and we will see this. We will use this calculation for the, we call this flash vaporization calculation. We are using these calculations to find our optimum surface separator design, okay? And in our next lecture, we'll show you how to calculate those. But that calculation basically sums the calculation of the density in our chapter 11 and gas and liquid equilibrium calculation in chapter 12. So it's just basically the review of these two. So and will not be in your final exam because the calculations are so lengthy. But your final exam would be one question from chapter 11, one question from chapter 12, and I'll give you one question from earlier chapters most probably. But the homework assignment again for these two chapters are posted. For chapter 11, the homework due is next week, and for chapter 12, the due is on May 1st, which is your final exam due. So final exam date. So try to complete these. If you want me to go over your homework assignment before your final, just shoot me an email. Send your homework. I'll check that. I'll let you know if you are doing it right or is there if there is any problem. Okay. So till now you have covered all the material that will come in your final exam. The next week we are going to quickly go over the surface separator design calculation, convergence pressure calculations, and I'll basically discuss more tips about your final exam. Okay. Again, don't forget the deadlines. Homework assignment number 6 next week, 7 on May 1st, and also your lab report. Again, remember your lab report is out of 200 points. It's a very important lab report. Just make sure to you do it correctly and make sure that you check that with TA, Josh, or with me before your submission. Okay? Thank you very much. I'll see you guys soon.